second. Share. Present. Okay, it works finally. So my name is Boris Denisov. Follow my pointer, please. This is my email. And I am lecturing on green demography, a part of International Risk Management lecture course. Why? Why demography and why green? So I'm explaining now. Global warming is really connected to population growth. Population growth is a subject of demography. Then I explain you an instrument to measure warming invoking a thermometer. Thermometer is the most important thing in this subject. Then I will try to explain you some histories of climate change. That means medieval warm period, little ice period, year without a summer, and some Gumilovica. Gumilov is a Russian author who wrote about ecology, let's say. And 1, 2. That's global warming. This is a timeline, and this is temperature. No, this is CO2 concentration. You see, here is the impressive growth. Then global warming is the ongoing rise of the average temperature of the Earth's climate system and has been demonstrated by direct temperature measurement and by measurement of various effects of the warming. One of the warming effect is temperature, or CO2 emissions. And this scale is a little bit shorter, and you see here is very impressive rise in CO2 emissions. This is global warming, and this is global temperature in the common era. There are two important things here. This blue part of this graph is indirect temperature measurement. That means these are estimates, and these are real measures which came from thermometer, and they started at 1980. That's very important. Then here is a temperature change in the last 50 years. You see that temperature change is not homogeneous. Some areas are more affected, others are not affected, and there is also some cold here near Antarctica. But the most affected area is around North Pole. It means tundra, and this is Russian tundra. Then global warming leads to habitat destruction. This, you see the picture of a skinny polar bear. This is very poor animal, and in summer some polar bear do not make the transition from their winter residence in the Svalbard Islands to the high Arctic, where they would find a plethora of prey. That means a lot of food. This is due to global climate change, which causes the ice around the islands to melt much earlier than previously. The bears need to adapt from their proper food to a diet of detritus, small animals, big eggs, and carcasses of marine animals. Very often they suffer starvation, and this is an example, and are doomed to die. The number of these starving animals is sadly increasing. That means the overall number is decreasing. And this is thermometer. You see now it is an office decoration. It is a Galilean thermometer invoked in 1593. We have to believe that it shows plus 24 degrees of Celsius. If you magnify, there is a small metal here attached to this vessel, and it shows 24. The individual flows rise or fall in proportion to their respective density and the density of the surrounding liquid as the temperature changes. It is named after Galileo Galilei because he discovered the principle on which the thermometer is based, that the density of a liquid changes in proportions to its temperature. Let me show you another one. This is a thermometer of my room, and it shows the temperature from minus 10 to plus 50 and something. This is a simple instrument to measure a temperature. The thermometer gradually evolved from Galilean thermoscope, which was the previous one, with the addition of scale in the early 17th century and standardization through the 17th and 18th centuries. There are two major things. One thing is zero, and another thing is another point on the thermometer. And the subject of investigation was how to graduate the scale, how to scale the temperature between zero, conventional zero, and something else, between two points of the temperature. This is the table of comparison of units of temperature. There are several scales: Romer, Réaumur, Newton, Delisle, Rankine, Kelvin, Fahrenheit, and Celsius. You see that Celsius is not the earliest one. It is the third from the last one, which is Rankine. And the subject matter of the various scale is the use. For instance, Kelvin is used in physics. Other, I don't know. So three scales have same nil. And the Celsius is most widely used, Celsius scale, probably due to its simplicity. Climate is connected to weather, and climate is what you expect and weather is what you get. This is an overview. Let me try to connect. This is a link. Now we are connecting to, and this This site shows the COVID impact on the European air traffic network. Now we have, you see this picture is very interesting. You could see this is April 16 and April 19 the year before, and you could compare the traffic. Compare the traffic. So again, to that same place. There. We saw the difference in air traffic, and this is a buoy. Buoy measures a temperature near the surface of the ocean, and the planes, each plane has a lot of temperature indicators. So the number of temperature indicators reduces with COVID infection. So we could expect the poorer quality of weather forecasts. And it is a risk for everything. Now to histories of climate change. This is medieval warm period. It is here. And as you can see, as you remember probably, this is the data and these are estimates. So the little ice age came to change the medieval warm period. What is medieval warm period? Medieval warm period is when Greenland was discovered. And this is a reconstruction of Viking house in Greenland. So medieval climate anomaly was a time of warm climate in the North Atlantic region, lasting from about 100 to 100 or 1000 to 1000 and a quarter. It was the warmest period since the Roman warm period, so there was another warm period. It was only in the 20th and 21st centuries that the Northern Hemisphere experienced higher temperatures. That means that our weather is better or warmer than it was in the times of Viking landing in Greenland. So from warm to cold, this was the year of climatic minimum. That means the weather was the coldest. And this is the book which describes this period. The little ice period was a period of cooling that occurred after the medieval warm period. It was not a true ice age. It has been conventionally defined as a period extended from 16th to 19th centuries, but some experts prefer an alternative time span from about 1300 to about 1850. The NASA Earth Observatory knows 3 particularly cold intervals, one beginning about this year and another here, the last year. Several causes have been proposed: cyclical lows in solar radiation, heightened volcanic activity, changes in the ocean circulation, variation in Earth's orbit and axial tilt orbital forcing, inherent variability in global climate, and decreases in the human population, for example, from the Black Death and the colonization of the Americas. And here we see at least two possible demographic reason of the climate change. This is mostly deal with mortality, and this is migration and the colonization of the Americas. This is a link to NASA Earth Observatory. Let's see what we have in this link. So the site is loading. This we'll see later, this dam failure in Uzbekistan. Reload again and present. Again here. So decreasing population was a feature of the Little Ice Age, unlike now. So we have the population bomb now. The Black Death is estimated to have killed 13 to 60% of Europe's population. In total, the plague may have reduced the world population from estimated 475 million to 375 million in the 14th century. It took about 200 years for the world population to recover to its previous level. William Rudiman proposed that this large population reduction in Europe, East Asia, and the Middle East caused a decrease in agricultural activity. Rudiman suggests deforestation took place, allowing more carbon dioxide uptake from the atmosphere, which may have been a factor in the cooling noted during the Little Ice Age. And then a great famine was also a part of this Little Ice Age. Rudiman hypothesized that a reduced population in the Americas after European contact in the 16th century could have had a similar effect. Other researchers support depopulation in the Americas as a factor, asserting that humans had cleared considerable amount of forests to support agriculture in the Americas before the arrival of Europeans brought on a population collapse. Neville Dahl and colleagues suggested that not only anthropogenic forest clearance played a role in reducing the amount of carbon sequestered in forests, but that humans set fires played a central role in reducing biomass in Amazonian and Central American forests before the arrival of Europeans and the concomitant spread of diseases during the Columbian exchange. Dahl and Neville calculated that reforestation on the tropical biomass on the Americas alone from 1500 to 1650 accounted for net carbon sequestration of 205 pg. Brierley conjectured that European arrival in the Americas caused mass deaths from epidemic disease, which caused much abandonment of farmland. which caused much return of forest, which sequestered greater levels of carbon dioxide. That means that the sequence of events is rather complicated, but this is determinism. A study of sediment cores and soil samples further suggests that carbon dioxide uptake via reforestation in the Americas could have contributed to the Little Ice Age. The depopulation is linked to a drop in carbon dioxide levels observed at Low Dome, Antarctica. A 211 study by the Carnegie Institution, Department of Global Ecology, assessed that Mongol invasion and conquests, which lasted almost 2 centuries, contributed to global cooling by depopulating vast regions and allowing for the return of carbon-absorbing forests over cultivated land. So Mongol invasions is an important period in Russian history. So there are a lot of research work in this area. And Gumilev was one of our most eminent researchers on this topic. According to official records about the English royal family and example of the best of society for whom records were kept, the average life expectancy in 1276 was 35 years. Between 1300 and 1325, during the Great Famine, it was 29 or 30 years, while between 1386 and 1375, during the plague, it was only 17 years. It demonstrates the relative steep drop between two dates of about 42%. And that means about a half. The Little Ice Age was nicely registered in European culture, especially in Holland. This is the census at Bethlehem, also known as the numbering in Bethlehem. This is also a demographic link. It is one of the first paintings in Western art to feature a significant snow landscape and was painted in the aftermath of the winter of 1565, which was one of the harshest winters on record. And the painter is Peter Bruegel, elder. And I missed some slides. So there is also an increasing population theory. It has been speculated that the increased human population living at high latitudes caused the Little Ice Age through deforestation. The increased albedo due to deforestation, more reflection of solar rays from snow-covered ground than dark tree-covered area could have had a profound effect on global temperatures. This is an opposite point of view and the link. And this is, again, Peter Bruegel, Hunter in the Snow, Hunters in the Snow. It is a very popular picture. And this in small font, there is its recall in cinema. And here you see the skating rink, something about this, and people playing hockey here with sticks, with modern sticks. And since that time, Holland is very famous for their skaters. and this is related to demography again, since this was a census after which the Herod decided to kill the kids. Then year without a summer, it's closer to modern times. You see the effect the year without a summer on European temperatures. It was most cold in France and least cold in Ukraine. Even the opposite, that's well, became warmer here. The year is known as the year without a summer, also the poverty year, and 1800 and froze to death because of severe climate abnormalities that caused average global temperature decrease by about 0.5 degrees of Celsius. Summer temperatures in Europe were the coldest on record between these years. This resulted in major food shortages across the Northern Hemisphere. So the food shortages may not increase population. And these are pictures from the North America. So the blast from the past, this is the link to the paper in Smithsonian Magazine. The eruption of Mount Tambora killed thousands, plunged much of the world into a fruitful chill and offers lessons for today. A year after the eruption, the effects were felt in the northeastern states of the US, where vital corn crops withered from killing frosts. Rapid cooling of burning ash that poured from the volcano formed pumice that choked harbors, disrupting trade and travel for months. You see that this ship or this vessel cannot achieve this vessel because of this. This is an ash floating in the ocean. A year without summer. This is a picture of Turner crossing the brook. The brook is over here. So the major thing is yellow skies. A guy analyzed the skies and found that it is yellow. And the yellowishness is a result of particles of volcano smoke or smoke. So it means atmospheric dust veil resulting from a large volcanic eruption in the tropics. Its effects were widespread, causing unseasonable weather, crop failures, and famine worldwide, and also this type of the sky. The volcano is here. This is the island with this volcano. This is Indonesia, modern. And the resulted area is Europe, which is far from here, and the New England is also far from this place. The eruption column reached the stratosphere at an altitude of more than 43 kilometers. It was on the 10th of April. The coarse ash particles settled out 1 to 2 weeks after the eruptions, but the finer ash particles stayed in the atmosphere from a few months to a few years at altitudes of 10 to 30 kilometers. Longitudinal winds spread these fine particles around the globe, creating optical phenomena. Prolonged and brilliantly colored sunsets and twilights was seen frequently in London. The glow of the twilight sky typically appeared orange or red near the horizon and purple or pink above. That's what I called yellow. In fact, it was orange or red, probably. This is cultural aftermath of the eruption. This is Dr. Frankenstein, and this is the author of Dr. Frankenstein. The group of the authors were isolated in the castle, and they had a race in writing a story, an evil story. So Shelley wrote a story about Frankenstein, and it was very popular, and it is very popular now. That's Lev Gumilov theory. This is the final portion of this lecture, of this part of lecture. Lev Gumilov, it is 100 years old. It's a Kazakhstan postmark. This is Lev Gumilov in the childhood. This is his father, Nikolai Gumilov, and his mother, Anna Akhmatova. They are very, very, very famous Russian poets. And this is Lev Gumilov, Eurasia Kazakhstan University. It's in Kazakh language, which I don't know. Gumilov attempted to explain the waves of nomadic migration by factors such as annual volumes of solar radiation, which determine the area of grasslands that could be used for grazing livestock. According to this idea, when the steppe areas shrank drastically, the nomads of Central Asia began moving to the fertile pastures of Europe or China. That means Mongol invasions in China and in Russia and further to Eastern Europe. Another Gumilov theory was passionality, which is more sophisticated and controversial. I do not understand it. It is also based upon ecological grounds, but is less clear, and it was severely criticized from various viewpoints due to its alleged anti-Semitism and neo-Nazism. These are some works of Gumilov which you could read. And this is a proof for his theory. This year, there are about a drought, expected drought in Russia. And this is a picture from NASA site, which we visited before. And this was probably a water reservoir. And the dam of this reservoir was broke, and water appears here, where it was not expected. So the theory of Gumilov was that Caspian Sea and Aral Sea, which are lakes, in fact, have opposite sea levels. When the Caspian is full, the Aral is empty, and vice versa. So now we see that Aral is becoming its survival, and it is a decay of Caspian Sea, which we expect in the near future. So what are the lessons for today? A demographic aftermath could be measured or unmeasurable, difficult to estimate. What we could measure easily, these are deaths and migration. Birth, which will not occur, is difficult to measure, and it is also a guesstimate. And the quiz for you, how will you estimate the demographic impact of COVID-19? So this is the end of this part of the lecture.